So now that we have the general idea, let's practice some graphing. Here I have listed 4 direct variation equations, and they are constants of variation on the side. How I found those was that I looked for the slope, or the a, in the y equals a times x. So when y equals 3x, your constant of variation is 3. So if we're going to graph that, we're going to start at the origin and have a slope of 3 over 1. So we'll start with the rise. We rise 3, 1, 2, 3, over the run. We go over 1. So we're going to mark a point there, and we're going to connect that line through our origin. Okay, let's do the same thing for y equals negative 2x. So your constant of variation is negative 2, which means your slope is negative 2, which is the same thing as negative 2 over 1. So let's do rise over run again. So we're going to go down 2, 1, 2, and we're going to go over 1 and put a point there. Now let's connect that line through our origin. Perfect. Now we just have 2 more to do. And for purposes of speeding it up, I'm just going to go ahead and graph them now that you have the general idea. Now, looking at all 4 of these graphed on our graph, what do you notice about the 4 equations? You're right, they all go through the origin. So that means that all of these have a y-intercept at 0. The same is true with all of the equations in the family of direct variation. Every single equation, y equals a times x, has a y-intercept at 0. To find out if a table of ordered pairs represents a direct variation equation, you need to use the ratio y over x, which you use to find a, your constant of variation. So for each pair, we're going to use our ratio. Our first pair is 1, 2. So our ratio would be 2 over 1. Our second pair is 3, 6. So our ratio would be 6 over 3. The following are the same way. We'll end up with negative 8 over negative 4, negative 14 over negative 7, and 16 over 8. Now we just need to see if these are equal to each other. Let's check. So 2 over 1 is obviously 2, 6 over 3, 2, negative 8 over negative 4, 2, I'm sensing a pattern, negative 14 over negative 7, 2, and 16 over 8, also 2. That means that our ratio is indeed constant, so 2 is our constant of variation, A. That means that this set of ordered pairs represents a direct variation equation. So our equation for this set could be y equals 2x, where 2 is the A that you found by using the ratio.